Hello, my name is Rob Earlam and I'm a technical evangelist with Sitecore, and today we're going to continue our look into Sitecore 10 and DevOps. In this session we're going to continue on from our previous continuous integration session to now take a look at how we can deploy our container images that we built before. In this session we're going to take a look at a few technologies that were newly supported with Sitecore 10, specifically Kubernetes and Azure Kubernetes Service, or AKS. So before we talk about our CD setup, let's just refresh ourselves on the CI/CD flow that we introduced in the previous session. So our developers are working away in their IDE of choice, making changes to the codebase. They finish their work and they commit their changes into the repository, in this case stored in GitHub. We're using an Azure DevOps pipeline to monitor this repository and trigger a new image build each time there's a commit to the repo. These images are built by Azure DevOps, and the new image version is pushed out to our ACR instance. But this isn't the only trigger we have configured. One of the base images we use might have changed. For example, an update to the base Windows image or similar that can also trigger a new build to occur. This is where the CI part of the process ends, and we now have our new images built and available for deployment. So this is where our CD elements start. Our release element is going to execute and start our deployment process. The first thing the CD element does is to push a new version of the Kubernetes specs into AKS, including pinning the deployments to the unique tag of the new images. AKS will now connect to the ACR instance and pull down these new images and build new deployments based on them. Of course, any Sitecore deployment isn't complete without a push of the content changes. Once the specs have been deployed, the content is then also pushed to the CM instance, running in AKS, and a publish is executed. Once this has happened, your end users can now browse the site and interact with the new containers running in AKS. Now in the first session we focused on the CI process, but in this one we want to look further into the continuous delivery side of things, digging into how we can deploy these images that we've just built out to an AKS cluster. Okay. So before we jump into the pipelines that have been configured, let's take a look at some key Kubernetes concepts. So what is Kubernetes? Well, you can see how the official Kubernetes documentation site describes it here. It was originally created by Google and they open sourced it back in 2014. Now you may see the name written as K8S, as in the title here. That abbreviation can look a little bit strange at first, but it's derived from the fact that there are 8 characters in between the K and the S in the name Kubernetes. So that's a pretty abstract way of describing Kubernetes you can see here. But why do we need it? Well, containers are a good way to bundle and run your applications. But in a production environment, you need to manage the containers that run the applications to ensure there's no downtime. For example, if a container goes down, another container needs to be started to replace it. Kubernetes provides you with a framework to run distributed systems resiliently. Kubernetes can expose a container using a DNS name or their own IP address. If traffic to a container is high, Kubernetes is able to load balance and distribute the network traffic so the deployment is stable. Kubernetes allows you to automatically mount a storage system of your choice. This could be local storage, public cloud providers, or many other ones. It also gives you the ability to describe the desired state for your deployment containers using Kubernetes, and it then changes the actual state to the desired state at a controlled rate. For example, you can automate Kubernetes to create new containers for your deployment, removing existing ones. Kubernetes restarts containers that fail. It replaces containers. It kills containers that don't respond to your user-defined health checks. And it doesn't advertise them as being publicly available to your customers and clients until they're ready to serve traffic. Kubernetes also lets you store and manage sensitive information, such as passwords, OAuth tokens, and SSH keys. You can deploy and update secrets and application configuration without rebuilding your container images, and without exposing your secrets in your stack configuration. So those benefits sound great, but what are the key concepts with Kubernetes that give us that functionality? Well, let's start by saying that Kubernetes is a huge topic. There's no way to cover it all in this session, so we're just going to touch on some of the basics. The first thing you're going to have to know about is the cluster. A cluster is the foundation of a Kubernetes setup. The Kubernetes object that will represent your containerized application all run inside of this cluster. A node represents a single entity within your cluster where your containers will be deployed out to, typically a VM. You will typically have more than one node in your production system to ensure high availability. A pod is the smallest deployable unit in Kubernetes. A pod is a group of one or more containers with shared storage and network resources, and a specification for how to run them. A deployment represents a desired state for one or more pods. You can describe this desired state, and then Kubernetes will change the actual state to match the desired state at a controlled rate. A container, we've discussed at length in other videos, but that represents an application being deployed. A service is what you use to expose an application running on a set of pods as a network service, allowing your containers to communicate with each other. You can also use them to configure more advanced networking concepts like load balancing. An ingress is an API object that manages external access to the services in a cluster, typically over HTTP. A typical example is using a reverse proxy like Nginx as your ingress to route incoming traffic to the correct application in your Kubernetes cluster. Finally, a namespace is used to group related resources within the cluster. The last concept for Kubernetes we need to discuss is secrets. You don't want to store things like credentials, passwords, API keys, and other secrets in your source controlled repository, as it makes it more difficult to change those should the need arise. Instead, you want to store those values externally to your images and pass them in at runtime. With Sitecore, these are things like your database connection details, your identity service secrets, certificate details, and your license data. The other advantage to passing them in at runtime is it means you can use the same image for all of your different environments. You don't have to build different images with different values per environment. So this might all seem a little bit abstract so far, so let's start to take a look at how these different elements interact with each other. So we start off with a control plane, and you have one or more instances backing this up to provide high availability. Next, we have one or more nodes. This is where our containers will be run. Each of these nodes contains a kubelet, which is what the control plane uses to control the node, and a container runtime used to execute the containers, in our case Docker. So we start by creating a deployment. As we mentioned on the previous slide, a deployment contains details of a desired state we want to create. This deployment will cause a number of pods to be created, and each pod will contain one or more containers. In this example, we have a single pod containing a single container. Finally, we create a service for that deployment, which assigns it an internal IP. But this deployment could contain multiple pods, in this case 2. When that happens, Kubernetes will scale the pods across the nodes. But notice how the service still wraps both of them though. There are different ways to configure this service, and a common one is as a load balancer, splitting the traffic between the 2 pods equally. And you can continue to scale this out further. Here we now have 5 pods being created, all with an instance of that single container inside, but still all wrapped by that same single service. So the last thing to discuss before we look at how this is applied to Sitecore is Azure Kubernetes Service, or AKS. This is Microsoft's managed Kubernetes service. They provide the control plane for you at no cost, and you only pay for the actual nodes themselves. And this is what we're going to be using for all our examples in the rest of this session. So let's take a look at the architecture we're going to be deploying to. In this case, it's going to be our staging server. So we're going to start off with our AKS cluster, which is going to house the Sitecore instance we're deploying. Next, we're going to set up our node. This is a non-production staging server, so we're just going to use a single Windows node as we don't need high availability for our non-prod site. Now we set up our ingress, an Nginx instance that will act as a reverse proxy for all of the services inside. It will map a domain to a specific service. Finally, we create our Sitecore deployments. You'll notice that each Sitecore instance is specified in its own deployment definition and with its own service. The reason we specify each instance as its own deployment is that we want to be able to scale them independently. If we have a single deployment with all of our containers defined, then we would lose the ability to individually scale the CD instance, but not the CM, for example. You'll notice that we also have an instance of the new .NET Core rendering host included as one of our instances as well. So this being a Sitecore deployment, we wouldn't be able to complete this without pushing our content changes. And with Sitecore 10, you can now use the new serialization framework and CLI to make it super easy to perform this action. You simply install the CLI onto your build agent, and you can then authenticate with your identity service instance, push your content changes, and even issue a publish after that. So what are the actual actions we're going to be performing as part of an automated build process? Well, we're going to start off by creating the namespace. We're then going to deploy our external specifications. These are used for data storage, so think things like SQL, Redis, and Solr. We then have some init specifications we run to initialize those external specs. After that, we deploy our actual application elements, so the different Sitecore architecture elements you're used to, your CD and your CM and the like. We're then going to patch some IP restrictions in. This is a non-production site, so we don't want this available to the public. We want this to be locked down so only certain people can access it. And after that, we're going to patch our container versions to be pinned to the unique tag that we just created for the build we're deploying. And that's our Kubernetes deployment completed. Next, we need to deploy our content. So we have a series of steps for that. We start by installing the Sitecore CLI. We then authenticate our build agent with our identity server instance. After that, we deserialize all of our content from disk into the Sitecore database, and then we issue a publish. And once that's complete, the site is ready to go. So let's take a look at this in action. Okay, so I've jumped over to PowerShell. I'm just going to paste a command in here. And what this is going to do is it's going to run an instance of the Kubernetes dashboard on my local machine connected to my AKS instance. What this allows us to do is to browse through a GUI interface showing us all of the different resources that have been deployed to AKS. So let's just switch over to the browser. We authenticate, and here we are connected to our Kubernetes instance. The first thing I'm going to do is I'm going to change over to my MVP staging namespace. This is a namespace that groups together all of the resources related to the MVP site. And this is the staging instance we're looking at. We're currently on the overview section, and this gives us basically a summary of everything that's been deployed here. We can see resource utilization at the top. Then we get some pie graphs showing the overall state of the different elements we have. If we move down, we can see information on all the different deployments that have happened. Remember we talked previously about the different deployments that are involved in this MVP staging site? You can see them each listed out here. You can see the job that was run to initialize our Solr container. And then we can see the pods backing up those deployments. Remember previously we said we're going to have a single pod created for each deployment, and that's what you can see here. Okay, so that's shown the Kubernetes dashboard and how everything's represented in there. But what we wanted to look at for this session was how we actually wired up that deployment. How our CI/CD pipeline actually created all of these items. So we're going to hop over now to Azure DevOps, and we're going to take a look at how it's been configured. Right, so I've jumped back over to Azure DevOps here, and you can see we have our MVP site project. I'm going to use the blue link here, and I'm just going to dive straight into our pipelines. We're going to load up the MVP site, and then just like we did in the previous video, we're going to use this edit button up here, and that's going to allow us to take a look at the YAML definition. Now previously we looked at the first stage, which was responsible for building our images and pushing those out to the ACR, as well as gathering some files together which we were going to use for part deployment. What we want to look at for this part is the second stage, which is going to make use of those assets to push those containers out to our site. So if we scroll down to here, we can see where the deploy stage starts. And you can see we start off by deploying our specifications out to AKS. This stage is made up of multiple different tasks which perform this, and we're going to take a look at each of these. We start off, first of all, by downloading the pipeline artifacts. This was the artifacts we created in the first stage and which we went over in the video previously. This contains all of the assets we need to action this deployment. Next, we create our staging namespace. Here we point to one specific YAML specification, which is what contains the namespace definition. We do this first because the namespace has to exist for all of the other elements to be deployed into. The chances are you're probably deploying out to an existing AKS infrastructure, but running this first every time means if you end up in a DR scenario, then this will all be created in the correct order, and it means you can use these same build scripts to deploy to a fresh brand new AKS instance, just as you can to a pre-existing one. Once that's finished, we do some token replacement. We have a heap of different variables specified in our Kubernetes specifications, and the reason for that is that you don't want to store those directly in your source code. If you did that, and those values changed, it means you'd have to recheck everything into your source control repository. Plus, with this being an open source project, we can't store things like secrets out in the open like that for security reasons. What this task does here is it goes and checks each of the different target file types we specified, and it'll go and match them to the variables defined in Azure DevOps, replace those values in there, and then they're ready with the correct values to be pushed out. Next, we start to work with our secrets. We have a series of secrets files in there holding things like connection string data, license data, TLS information. All of those again are stored into source control with variable tokens in them instead of the actual secret data themselves. This baked secrets parameter here will actually create all these secrets correctly, ready to be deployed. And that's what we do in the next step. Here we're actually taking our secrets data that was baked in the previous task, which is this bake.manifest bundle, and we're going to push it out to our AKS instance. Notice we're targeting the MVP staging namespace here because that's the actual site we're deploying to. Once we've finished this, our namespace is ready, our secrets have all been deployed. Now we're going to deploy our external specifications. These are all the data storage containers we're going to use, so Solr and SQL in our case. You can see the specifications exist within their own external folder, and that allows this task to target them specifically. Once that's finished, we then run our initialization jobs. We just saw the job listed in the Kubernetes dashboard, and that's there to basically initialize our data storage containers and make sure they're ready for Sitecore to run. Now, we actually work on deploying our Sitecore roles. This is all the Sitecore elements that we have to push out. So CD, CM, rendering host, ID server, everything we need to run Sitecore is going to be deployed in this task here. We point it to the Kubernetes specifications folder we created in the asset, and then we just run this apply command. It's going to iterate through all of the different specifications in there and deploy them all out to our AKS instance. Now the next task we do here probably isn't something you're going to do on every deployment, but more than likely you will do on your non-prods. What we're doing here is we're updating our ingress, and in our ingress we've specified an whitelist source range. So that's a set of IPs who are allowed to communicate through that ingress and access these different application containers. That's because this is a non-production instance. We don't want this available to the whole wide world, so we need to set some IP whitelisting on this. You'll notice as well that we're using an IP whitelist variable. That means that the actual IPs we're whitelisting are stored in an Azure DevOps variable as well, making it really easy to update, and once more, meaning that data isn't stored directly in your source control repository. After that, what we want to do is update each of the different application containers we've created to point to the new unique tag we've just pushed into our ACR instance. And we do this one by one. You can see we update our SQL image. We update our identity server image, our CM, CD, and our rendering host. Each of these tasks goes over to the AKS instance and tells the deployment that it needs to work against this new version of the image which exists in the container registry. That will cause AKS to pull those images and recreate the containers based on that unique tag. And at that point, the deployment of the container specifications has been completed. Our AKS instance is ready to run. But, as always, with this being a Sitecore deployment, we've got to get our content pushed out. And that's the final stage of this deployment. Here you can see we have our deserialized content to staging deployment. And this is pretty straightforward. There's only two tasks at play here. The first one downloads the artifact which we created in our build previously, and the next one runs a PowerShell script. So the PowerShell script is really simple because it leverages the new Sitecore content serialization framework and the new Sitecore CLI. It really is only a couple of commands. We start by registering the Sitecore NuGet feed, and then we do an install of the Sitecore CLI. After that, we call .NET Sitecore login to authenticate against our ID server instance. We call .NET Sitecore serialization push to push out all of our content changes into the master database. Then finally, we run a .NET Sitecore publish, which is going to perform a full publish of the Sitecore database. And just like that, we have a fully deployed staging instance. Our code has been built into new container images and deployed to our ACR. Our AKS instance has been updated with new specification data, specifying the unique tag it needs to create the deployments that we need. Once that's finished, we do a complete deserialization of our content and database publish. So that means every commit that happens for this repository is going to cause a full rebuild, but will leave you with a functioning site at the end. Okay, so I just want to finish with some tips and tricks here to get you started. Remember not to store any of your secrets directly in your repository. These should be stored as CI variables, which are then used to populate your Kubernetes secrets. Remember to use Kubernetes namespaces to group resources. I like to think of namespaces here as kind of similar to resource groups in Azure. It's a good way for you to group application elements that have a related lifecycle. You're going to need to plan how you're going to handle your data storage roles in production. This could be using PaaS elements like Azure SQL, or it could be standing up these elements inside containers themselves. But if you do that, they need to be hosted in a different node pool. Don't forget to automate your content deployments, just as you would with traditional non-container based deployments. For true high availability, you may have to plan for multiple AKS clusters in different regions. Thanks for watching, and don't forget to follow the Learn Sitecore hashtag for future videos.